Oh, by the way, Marie, we have another person from Jamaica. You know, he's not here. I'm not seeing him. Um, I'm not sure if you know him. Do you know Javon Green, by chance? Chanel, do you know Javon
Sir?
Green? Yeah, Marie.
No, sir.
Maria, everything alright?
Hello?
Yeah. Marie, you hear me? Don't know going on the Wi-Fi, boy. Like the Wi-Fi giving proper problems.
Hello? Okay. Oh my god. Wait. Oh, okay. So you can hear me?
Yeah, I can hear you.
This is
Wait, hello? You okay?
I do not know this, and I am not from Jamaica.
Oh wait, I probably make a mistake in saying the name, but Chanel is from Jamaica. Chanel is from Jamaica, and I was asking her if she know Javon. I have this habit of sometimes I want to say something, and I know I want to say in my brain, but like what comes out my mouth is different, and I typically mix up people's names. I apologize. Yeah, but let's resume. So in the last class we had start mass and weight. Adil, do you remember what mass was? Adil, do you remember what mass was?
Yeah,
What's mass?
yeah.
What's mass?
Ma- Mass is like the weight of the object.
Nah, weight and mass are actually two very different things. They're two different things, eh? Mass and weight, two very different things. So mass is the amount of matter that a body or object has. It never changes. However, weight is the force exerted on an object in a gravitational field, and weight could change depending on the gravity. So, here what I think Ollie would have to copy this down. I want you all to copy down mass and weight, right? So, Adil, you hear me?
Yes, sir.
Adil, is mass and weight the same thing?
No.
No, it is not the same thing. Mass and weight are not the same thing. I want you all to get that. Wait, so right now my Wi-Fi is giving some trouble. Yeah, right now my Wi-Fi is giving some trouble. Are you all hearing me or no? You all
Yes,
hear me?
sir.
Am I breaking up a lot? Well,
No,
guys,
sir.
no. Okay, I don't hear an Adele, right? Chanel, you hear me?
Yes, sir.
Right. What do you think mass is? In your opinion, what do you think mass is?
It's basically like what makes up something, like the amount of like molecules or matter in an object.
Yeah, that's correct. And do you think that changes or do you think that's fixed? Like imagine
Fixed.
you had a metal cube. You had a metal cube. The volume that that metal cube takes up is always going to remain the same. So it's the amount of molecules and particles that make it up remains constant. So it's fixed. Right, that's fixed. So mass is simply defined as the amount of matter contained in an object. It is a measure of an object's inertia or resistance to change in motion. Chanel, which one would you be? Okay, imagine both objects were in motion. Which one would be harder to stop? Fat Man Bob or Megan?
Batman Bob.
Yeah. Megan, you remember this example? Megan, this was you, Ent. I think this was you or her draw.
Yes, sir.
Yeah, okay, I hear you now. Good. So, the more mass an object has, the harder it's going to be to stop or change or like cause a change in motion. And that's defined as inertia. So that's what mass is. Weight. So Megan, do you remember what weight was? Tell me, Megan, do you remember what weight was? From the last.
Gravity.
Well, I wouldn't say weight is gravity, but weight.
Gravity.
Now, weight is not gravity, but weight is dependent on gravity. So Megan, on Earth, okay, let's just say stand up on somebody, right? If you stand up on somebody and they might tell you get off. I know weird example, but if you
Yeah.
use it right, the reason for that is because you'll be crushing their organs, and you'll be like, you will be exerting a downward force on the person. That will be very uncomfortable. Now, the reason why you would be exerting a downward force is because of the matter in your body, right, and the gravitational field constant. Because of gravity basically attracts you to the center of the earth. So, because of the mass you have, gravity is going to cause you to act downwards. So it's going to give you a force, which is weight. Weight is a force. So because you have mass and you're on Earth, Earth has gravity. By you standing on something, you have a downward force. You have weight. You understand or no?
Yes, sir.
Let me say that again. So all bodies on Earth, gravity wants to pull the object towards the center of Earth. Right? It's gonna pull the object. It's gonna basically pull it downwards. So the more mass you have, the greater the weight. The less mass you have, the lower the weight. And the stronger the gravitational field strength, the greater the force is going to be. Because Megan, gravity, you can think of gravity as what's pulling you to the center of Earth. If the gravity was more, the force would be more. If the gravity was less, the force would be less. So Megan, let me give you an example. On Earth, the gravity is 10. What's the gravity on the moon, boy? Let me give me a second. One moment. Okay, yeah, so Megan, on Earth the gravity is 10. In the moon it is 1.625. Megan, where would you weigh more? On the Earth or on the moon?
On Earth.
Exactly. Chanel, gravity is like the tendency to attract a body or an object to the center of whatever celestial body it is, like whether it be Earth, whether it be the moon. That's what gravity is. It's like what attracts you to the ground. Chanel, you understand what I'm saying? Gravity.
Yes, sir.
And the stronger the gravity, the greater the weight is going to be, because you'll experience a greater pull towards the center of Earth. The weaker the gravity, the lesser that pull is going to be. So weight is dependent on mass and gravity. The more mass you have, the greater the weight. The stronger the gravitational field strength, the greater the weight. So I want you all to copy these definitions down. Mass and weight. Javon, good morning.
Morning, sir.
Right, so Javon, we have some company. So Chanel is also from Jamaica. Yeah. By off chance, you all know each other? Yeah or nah?
No, sir.
Nah?
No, sir.
Uh,
Sir, I attend the all-girls school.
I see, I see, I see. Yeah, well, that wouldn't make sense then. Javon, do you attend a mixed school or all boys school?
Yes, sir. Mixed schools.
Oh, okay, okay. That's so cool though. We have like inter-Caribbean representation. Like I didn't think I'd have students from Jamaica in my class. That's crazy. All right, so I'm giving you all 3 minutes to copy this down. I think that's all you might need. So by 11, you should have all of this copied down. So Megan, are you okay and able to distinguish between mass and weight?
Yes, sir.
All right. Marie, talk to me. Marie, which one do you think changes, mass or weight? Which one could change? Marie, if you're talking, I can't hear.
Sir? Okay, yeah, wait.
Weight could change.
I don't know what to fix on my
And what does weight depend on?
so gravity.
Gravity and what as well? If somebody okay.
Sorry, force.
Nah, weight is a force. Weight is a force. Alright, let me ask you a question.
Right.
Which one, okay, which one, if they sit down on you, would kill you? Fat Man Bob or Megan?
Fat man, bro.
Right, so Fat Man Bob would exert a greater downward force. Right, weight. He'd have a greater weight. So these two persons here, the only difference really is their mass. Is that not true?
Yes.
Who had the greater mass?
Fat man, Bob.
Exactly. Both of them on Earth, so both of them are experiencing the same gravity. But Fat Man Bob has the greater weight. He has a greater weight because he has a greater
Mass.
exactly. So weight is dependent on gravity and mass. Unless unless Bob don't go to the gym, he mass can remain the same. One more minute to copy this down and we're gonna move on. Right, so Javon, do you understand the distinction between mass and weight?
Yes, sir.
Right, Javon, do you know the formula that links mass and weight together?
Sir, weight is mass times gravity, and gravity. Weight is mass times gravity.
Correct. Weight is equal to mass times gravity. That's correct. Okay, so I'm going to move on now. So we understand what mass and weight is. This is a formula that relates weight, mass, and gravity. So weight is equal to the product of mass and gravity. And this makes sense. Because the more mass you have, the greater the weight. The more gravity you have, the greater the weight. This makes sense. So weight is equal to mass times gravity. Copy this down quickly. Now, we need to understand that weight is actually a what? What is weight? Anybody want to tell me? Weight is a what? Megan, you tell me. Weight is actually a what? That's what F.
Force.
Yeah, weight is actually a force because
Force.
because again, Megan, if you stand up on somebody, wouldn't you be exerting a downward force on them? Like you're pushing them down?
Yes, sir.
Exactly. So, copy down both of these formulas. So W is equal to mg, weight is equal to mass times gravity. Additionally, if we generalize that formula, F is force, and again, force is measured in newtons. M is mass measured in kilograms in physics. And what does A stand for? Anybody know? Does anybody know what A?
Acceleration.
Acceleration.
Yeah, Adil. Acceleration.
Acceleration.
That's correct. So make sure you guys have this on lock. I'm giving you all 1 minute to copy. I don't know if I'll can do that. But at 11:02, we're going to move on. W is equal to mg and F is equal to ma. Remember those two formulas. F is equal to ma and W is equal to mg. Okay, does everybody have these formulas copied down? Guys, yes, no, maybe? Let me know.
Yes, sir.
Yes, sir.
Alright, cool. I'm going to move on now. Let me give you all a question one time. Okay, I would like you guys to try question 8. Try question 8 for me. So the acceleration due to gravity on Earth's moon is 1.6 meters per second squared. Guys, you see that ms minus 2? You read it as meters per second squared. Because s to the power minus 2 actually means m over s squared. Right? So gravity on moon is 1.6 meters per second squared. They're saying a 75 kg astronaut walks on its surface. They wanted to determine his mass and his weight. So I cannot throw you all into the ocean a little bit, but Megan, I think you know what to do for question 8? Well, really question 1. Let me know. Yeah or nah, Megan? Talk to me.
No.
Nah? Alright, so Megan, What's the formula, you know?
No, sir.
Alright, so I'll do this question with you guys then. But I think you all could do it. Okay, do any of you guys think you have ideas to how to do the first question? Adil, Chanel, Marie, Javon, let me know, guys. Taking those on no? Alright, let's look at it. I did kind of throw you guys into the ocean, I suppose. Okay, cool. So, guys, what's the formula? Oh, so Megan, what's the formula relating mass and weight? Megan? I believe you would have copied it down, would you not?
Yes, sir.
Okay, what's the formula then? Relating weight, mass, and gravity.
Weight is equal to mass times gravity.
Right. So weight is equal to mass times gravity. Cool. Let's look at the question. Okay. Alright, Megan, you okay?
Yes, sir.
Alright, so I'll wait to read the question for now.
The acceleration due to gravity on the Earth's moon is 1.6 meter per second square. If a 75 kg astronaut walks on its surface, determine his mass and weight.
Okay. So Megan, in the formula, I just want to recap, right? W represents weight, and weight is measured in what?
Newton.
Right? And weight is actually an example of a?
Force.
Alright, this is a force. A upward force or downward force?
Downward.
Cool. M represents what?
Mass.
And it's the amount of what? Wait, what is it? What's mass?
Kilograms.
Well, we measure it in kilograms, yeah. But what actually is it? What is it?
The amount of matter in a body.
Yeah? Amount of matter in our body, cool. And G, what's G?
Acceleration due to gravity.
Right, so that's actually acceleration due to gravity. What do we measure acceleration in?
Newtons or kg.
Did you all copy that down? Don't study this. Don't study that, okay? Acceleration is measured in meter per second squared. You would see that, or you would see ms minus 2. Okay? Tell me if you're with me, Megan.
Yes, sir.
So when you read this question, they're telling you the acceleration due to gravity on Earth's moon is 1.6 ms minus 2. So if you were to say, Megan, which variable does that correspond to? W, M, or G?
G.
And that's for Earth or that's for the moon?
The moon.
That's the moon, right? Because it said the Earth's moon. Okay, so cool. We have a piece of information here. We know that G on the moon is 1.6 meter per second squared. We have that. What else are they giving us in the question?
the mass.
Right. The astronaut has a mass of what?
75 kg.
Although I have a question. Is it legal for me to say the astronaut weighs 75 kg? Adele, Chanel, Marie, Megan, Javon. Is it legal for me to say the astronaut weighs 75 kg? Could I say that?
No.
Chanel, could I say the astronaut weighs 75 kg?
No, sir.
No, because that's mass, that's not weight. People will say that. That's wrong. People will say, I weigh in 500 pounds. I weigh in 75 kg. No, you're not. Alright? That's your mass. Okay, so now you can correct your friends and rage bait them. Alright, yeah, so Megan, the mass M is 75 kg. You with me?
Yes, sir.
And we need to find. Oh, this question was real easy. Look how simple this is, eh? So, Megan, what's the first thing they want us to answer?
Is the mass.
What's the mass?
75 kg.
Bam, you have a mark already. And what do you want me to find in the second part?
The weight.
What's the formula for weight?
Mass times gravity.
Do we know what the mass of the astronaut is?
Yes, sir.
What is it?
75.
Right, and what's the gravitational field strength on the moon?
1.6 meter per second square.
Right. So what's 75 by 1.6?
120.
You're okay with that? 120?
Yes, sir.
Yes, sir.
And what will the units for that be? Someone
Newton.
Newton.
Yeah, newtons. Megan, what do you think? That was hard or that was easy?
It was easy.
I'm telling you, it's just look a little hard, but not hard. Right. So, any volunteers to do the second question? It's a bit harder, but I still think we could figure it out. I don't think it's scary territory. Any volunteers? Any volunteers? Anybody willing to help me with this one? How are you moving so, boy?
Sir, I'll go.
I appreciate it. Anybody here is beyond TikTok plenty?
You
Yes,
can't
sir.
watch sound.
You know that one sticker where like the person just handing out like a cup like for money?
Yes, sir.
That's how I'm feeling. Like asking y'all who help me. Alright, so Chanel, read the question and let's try to analyze it.
The acceleration due to gravity on Earth is 9.8 meters per second squared. A trailer has a mass of 3,000 kilograms. Each wheel of the trailer is able to exert a maximum of 5,000 newtons of reaction force. Calculate the minimum number of wheels the trailer should have.
Alright. Now we're looking at two concepts here. Let me ask you also a question, right? If you want the trailer to be held up and okay, let's look at this logically. So we have a trailer here. What will the trailer have? Tamashina, what will the trailer have?
Weight.
It would have weight because it has mass, right? You with me?
Yes.
And this weight, it would act in what direction?
Downward.
Right, so this trailer is gonna have a weight. Now, what by chance, what is the mass of the trailer?
3,000.
3,000 kg. Let's analyze the problem, right? So, in the question, Chanel, what was the acceleration on Earth? What was E?
9.8.
Right, so that's A or that's G, however you want to think about it. F is equal to MA or W is equal to MG. Either one is fine. But the gravity is 9.8 ms minus 2. They're telling us the mass of the trailer is what?
3,000 kilograms.
So if we are analyzing this problem, you have a trailer. A trailer will exert a downward force. Is it possible for me to figure out that downward force?
Yes, sir.
How would I do that?
By using the formula for weight.
Which is?
Mass times gravity.
What's the mass?
3,000.
The gravity?
9.8.
So what's the weight of the trailer?
29,400 newtons.
Aha! Now, guys, if I want to hold up that weight, don't I need to have enough wheels to be able to sustain that? Think about it.
Yes, sir.
Guys, if I put one wheel, you think that wheel will get crushed? Or I think it'll be able to hold up that weight?
Crushed.
How about the rest of you all? Somebody else. How much weight could one wheel hold up? One wheel.
5,000 Newton.
Yeah, one wheel could sustain 5,000 newtons. Marie, you seeing that? In the question, I said one wheel has a reaction force of 5,000 newtons. Marie?
Yes, sir.
Adil, you seeing that, right? Megan? Or you think one wheel will be enough?
No, sir.
No, so one wheel could hold 5,000 newtons of force. Question: do you think the wheel is gonna exert a downward force or like an upward force? Reaction force. That's so keen. Reaction force, they say. A wheel. The wheel is holding up the trailer. What direction do you think the wheel's force would be exerted? Up or down? Tell me now.
Sir, it would be a downward force.
Nah. Think about it, right, Chanel? They're using the word reaction. The weight of the trailer is going to act downward. So if you want to sustain the weight of the trailer, you'll have to exert an upward force to cancel off the downward force.
Oh, yes, sir. So that it could hold up. Yes, sir.
Yeah. That's why they say in reaction force, because you're reacting to the downward force. The wheels are reacting to the downward force. So they have to act upwards. Now, let's think. How much weight do we need to sustain?
The 29,400.
Exactly. How much one wheel could take?
5,000.
So I'll do the maths. How am I going to figure out how much wheels I need?
Going to have to divide.
Talk to me, we have to divide.
You're divided by 5,000.
Divide what by 5,000?
So the 29,400.
Yeah. 29,400 divided by 5,000. Chanel, Marie, Adil, Megan, are you understand that or no? Like if you're very confused, just tell me. I'll try to explain it.
Yes, sir. I understand.
I understand, sir.
Alright.
I understand, sir.
Because again, we need to sustain 29,400 newtons. We know one wheel could hold for 5,000 newtons, so we just divide to find out how much wheels we need. So what would I get?
5.88.
You get 5.88? Let me ask you all a question. You think you could have 5.88 wheels? Can I have 0.88 of a wheel?
No, sir.
So where's the actual number of wheels?
5.
Sir, 6.
6. Now you have to think logically here, Chanel. Chanel, where's the weight I have to hold up?
29,000.
29,400, right? I want you to multiply 5 by 5,000 newtons. Tell me how much force I'm holding up there.
25.
Is that enough to hold up 29,400?
No, sir.
Nah, so we have to round up. 5.88 is essentially 6. You can only have whole numbers of wheels. You can't have like a fraction of a wheel. And you're not going to round down, you have to round up because you want to cater for the force. Some of you understand that.
Yes, sir.
Right, so 6 wheels. Right. And each of these wheels is going to exert at what kind of force? A upward or a downward force? Tell me, Megan.
Downward.
Megan, if you want to hold up something, are you exerting an upward force or a downward force? You want to hold up something. You want to keep something up.
Upward.
And the wheels, what are they holding up?
The trailer.
Exactly. So each wheel is going to exert an upward force of how much newtons?
29. Oh,
No. How much force could every wheel exert? They said that in the question.
5,000.
Exactly. So if we use 6 wheels, 6 by 5,000, what is that? What's 6 by 5,000?
30,000.
Does that cover the amount of weight that the trailer is exerting?
Yes, sir.
And change, right? Yeah. Question. I'll think logically, right? If you were designing a vehicle, do you want to put tires that could stand just the weight of the car? Adil, Chanel, Marie, Javon, Megan. If you making a car, will you put tires that could only handle the weight of the car itself?
No, sir.
Why? Explain why.
Because people don't listen.
What do you mean people don't listen?
Somebody will like put some extra weight on it.
Even funnier than that, Marie. If you design the car, the tires only to handle the weight of the car, what happen if somebody go to drive the car? You understand? What happen? Marie, what happen? If you design the tires only to handle the weight of the car alone, when somebody go to drive the car, the tires might burst. Yeah. When Fat Man Bob goes to drive that car, he ain't going nowhere. He's staying right there. He getting fatter. Anyways, all you understand these things?
Yes, sir.
Alright. I want to give you all one more question to see if all you really understand it. I don't feel 100% confident. I don't. Come on a second, I'm coming up with that question. a second. Megan. So Megan, anytime you see reaction force, is that upward force or downward force?
Upward.
Yeah, it typically means reaction force. Right?
Yep.
Alright, let me give you all a question. I want to see if you all could think. I'm going to give you all 5 minutes for this one. Good luck. Here's the question. Go. Come on, guys, lock in. You'll have this. Are you all getting through?
Yes, sir.
All right, Megan, talk to me. Talk to me, Megan. What's going on?
Yes, you were the first part or the second part.
All right. Chanel, I saw you on mute. What's going on?
I'm good.
All right, Adil, talk to me. What's going on? Adil, Hussein, what's going on? We're not hearing that at all. Okay, I'm going to give you all 2 more minutes. 11:33. Should get something. Alright, so Marie, we have to work on how you're writing and working. You wouldn't get full marks. There's like a specific structure you must follow. You have to follow that structure. So I'll show you what you have to do.
Yes, sir.
Like parts of physics, you write the formula, then you transpose, then you substitute. But the first question is correct. The other one is correct as well. Um, everything is correct. It's just the way it's just the way it states and you're working how to improve.
Yes, sir.
Alright, so Javon, you hear me?
Yes, sir.
In physics, we are very careful about how we write our formula. You might actually get that wrong because you use capital W, you use capital M, and you use capital G. I know, crazy. You have to be very careful. Weight, mass, and gravity are all common letters, not capital letters.
Yes, sir.
Because like capital M, W, and G might represent other things in physics, so you have to be careful. Okay, I'm happy to see what y'all are coming up with. Cool. Chanel, Megan, Adele. What's going
Yes,
on?
sir. Sir, I'm good.
Alright, so you're working, right? As soon as you're done, Megan and Chanel, send me what you come up with.
Sir, on Zoom.
No, via my number. On WhatsApp.
Okay, sir.
Okay, Megan, I like how you're writing, you're working, but there's some improvement we could make. Right? But you all have the gist. Chanel, I'm waiting on the answer from you, and then we'll proceed to correct it. Megan, I must say, like, from the first class to now, I don't know, maybe you were just nervous in the first class, but now I see like you're settled and you're doing good. Were you like real nervous in the first class?
Yes, sir.
Oh, I see. Because like, you're moving good now, like normal, like, you're doing good stuff. I really don't have no complaints now. Anxiety is a hell of a thing.
Yes, sir.
Yeah, Chanel, that's correct. But hey, Chanel, even if it's scrappy, I had to see you working, because I need to give you feedback on how you write and you're working. In physics, they're very picky on how you write your working. So let me show you all
Okay,
the.
sir.
So let me show you guys the ideal way to go about writing your working. So Marie. So Marie, in physics, these are typically the structure they're looking for. You're gonna state your formula. If you have to make something the subject of the formula, you do that. So you transpose if you need to. And then you substitute. And in physics, don't ever forget your units. You put your units. In maths, they might give you a little might give you a bly, but in physics, you're really not getting no bly. Put units. Okay, so Marie, in the first question, they're saying calculate the student's weight on Earth, where the gravitational field strength is 10 newtons per kilogram. So Marie, they gave us the I'm gonna put down my information, right? They gave us the mass, Javon common M. They gave us the mass of 60 kg, and they gave us the gravitational field strength G as 10 newtons per kg. And they want us to find weight. Weight is W is equal to mass times gravity. So as you can see, Maria, I've written my formula. I don't have to transpose, so my next step is just substitution. My mass is 60, so I plug in that's substitution, and I substitute G for 10. So weight is equal to 600, and you put your units, 600 newtons. That's what they want to see. Alright, part 2 now. On the moon, the student's weight is 96 newtons. So on the moon, the weight is 96 newtons, and they want us to calculate the gravitational field strength. So they want us to calculate for G. Okay, and earlier we knew that the mass was 60 kg. So Marie, you're gonna put down the original formula first. So W is equal to mg. What do we want to find for though? Tell me, what do we want to find for?
Gravity.
We want to find for gravity. So we need to make G the subject of the formula. So I need to isolate G. You know, Marie, you just do this in maths. So we need to isolate G. So what do I need to do on both sides? Or what do I have to do to get rid of anything that's not supposed to be there by the G?
Is it, I think it's multiplied by M?
No, no more.
Times? Divide?
Okay, I want you to think logically. I don't want you to guess. I don't ever want you to guess. And
Just move it to the next side.
okay. By the way, did you use ChatGPT for your answer, or did you do it by yourself?
Which answer?
Like the solution you sent me. Like you did it by yourself, right?
By myself.
Alright. Because you do the correct thing, you know, it's 96 by 60. That is the correct thing.
Yeah.
But we put any full work in now. So
Yeah.
we need to find for gravity, G. We need to make G the subject of the formula. What shouldn't be there if I want to find for G?
M.
Right. M is being multiplied by G, divided by G, added to G. What's the relationship?
It's being multiplied by G.
So if you move it across, it will turn to what?
Divide.
Right. So W over M is equal to G. So you have the formula now. So now we can do this substitution. So the weight is 96, the mass is 60, and here you get the answer. In physics, typically you round the answer off to 2 decimal places, right? 2 decimal places.
So it's 1.60 meters plus.
Alright, yeah, so it'll be 1.60. I would write it as 1.60. I'll put in that 0 there as a placeholder, right? Just because I like to see the 2 decimal places. You could say ms minus 2, or you could say Newton kg minus 1. Both are fine. If you're wondering where to get Newton per kg from, let me show you. Marie, what's the unit for weight?
Newton.
Right, so you have newtons on top. What's the unit for mass?
And over mass. kg.
Right, and Newton per kg is the same thing as Newton per kg minus 1. You understand?
Yes.
Alright, nice. So that's the working they want to see. You put on your formula, you transpose if you need to, then you substitute. Then in part 3, state what happens to the student's mass. Right, so 3. Mass is constant. But our mass is constant and never changes. Weight. Where did he weigh more? On the Earth or on the Moon? On the Earth or on the Moon? Guys, where did he weigh more?
On Earth.
On Earth. So weight on Moon. Wait. I'll say weight decreased on Moon from 600 newtons. So you want to be quantitative about this. You want to state, like the quantity it dropped down to. So I say the weight decreased on Moon from 600 newtons. Actually, that's not the best way to say it. But the point is, you need to put what it reduced by. So I'll just write it as simple as it is. So long story short, the weight simply decreased. So weight decreased from 600 newtons to 96 newtons. This is what they're looking for. They're looking for you stating a reason, like numerical values. So the weight decreased from 600 newtons to 96 newtons due to the weaker that's the ideal answer. So yeah, you all could take a screenshot, and this is the guideline of how we're going to move forward. You state the formula, you transpose if you need to, you substitute, you put the units. Are you ready to move on?
Yes, sir.
Yes, sir.
Alright, cool. Let's move on.
So where's transport? I mean,
Alright, transpose just means to make something the subject of the formula. So you see how you move across double M? That's transpose.
okay.
Yeah. Okay. Now we're going to move on to center of gravity and stability. Before we even start, I have a question. I like to think physics is very intuitive. A lot of these things we already understand. Which one will be more stable? A short board house or the Burj Khalifa? I don't know if you all know what the Burj Khalifa. Do you all know what that is?
Yes, sir.
Adele, Chanel, Marie, Megan, all you know
Yes,
what
sir.
Burj Khalifa?
Yes, sir.
Okay, what do you all think is more stable? Like if I had a tornado, which one would be more likely to topple over?
The Burj Khalifa.
What do you think? Marie, Megan, Javon, Adele.
Yes, sir. The Burj Khalifa.
Anybody can say why? Like intuitively, it makes sense. Megan, and this more likely to topple over.
Yes, sir.
You ever played Jenga before?
Yes, sir.
And until this get real hard when people keep stacking it on top of each other and then like the height increasing.
Yes, sir.
Right. So you understand the logic. Why do you think this one is more stable? Or what's saying? Why do you think this one is more likely to topple over? The taller one. You think you can give me any answer? Or you just know it makes sense? Thelma. You can give me a reason or you just know it makes sense? Anybody can give me a reason? Or you don't leave me hanging now, gosh. Megan, yes or no? Like, let me know.
It makes sense, sir.
But you don't understand why it makes sense.
Yes, sir.
Now I understand. It makes sense in a way, just can't explain why. Well, the reason for that is because the center of gravity is lower. That's why. For this building, the center of gravity is here. For this building, the center of gravity might be here. The higher the center of gravity, the lower the stability. That's what we're looking for in terms of physics. So objects balance at a point called the center of gravity. Now the center of gravity is a point at which all the weight of a body acts. So let me show you what I mean. So guys, you'll see I have this Apple Pencil here.
Yes, sir.
Okay. Yeah. My camera on.
When you finish it,
At 12:30.
okay. I just know.
Yeah.
Okay.
What going on?
I wanted to go right by Amanda father day to change your father. He food have crap up now. He
Oh, he's criminal, sure.
yeah, that and to change the case.
Alright. Alright, so guys, let's see I have this Apple Pencil here, right?
Yes, sir.
Now, we understand that this Apple Pencil is made up of matter. And because it has matter, it has a what? What does it have? Matter. Has matter, so it has what?
Mass.
Mass. And because it has mass, and we're on Earth, it has what? So it has mass,
Weight.
and we're on Earth, so it have weight. Now, the center of gravity is where all of that weight is acting down on. So if I was to suspend it, okay, I have a question, right? We just do the question with the trailer and the wheels. Wasn't the wheels able to hold up the weight of the trailer?
Yes, sir.
Right, so here what I was saying. We have this Apple Pencil that have weight. If I could find the center of gravity, I could hold it up at that one point. So let me see if I could find the center of gravity. Oh, I think that's the center of gravity there. Oh, I think this was the center of gravity here.
No, sir.
Megan, you think this is the center of gravity?
No, sir.
What about... That wasn't the center of gravity either. Let me see. I think this is the center of gravity.
Yes, sir.
Yes, sir.
Right. So this point over here, that's the center of gravity because I'm holding the entire weight of the Apple Pencil at this point. So if I were to draw a diagram of the Apple Pencil, at the center of the Apple Pencil is where all of the weight is acting down on, and we call that point D. What's that point called? We call it COG, center of gravity. Alright, do you all understand the logic? Right, that makes sense, like, the center of gravity. I don't know how else to explain that. Adil, Megan, Chanel, like that makes sense, right?
Yes, sir.
Yes, sir.
So if I look at that, see the force, all of the force would have been acting down on my finger. And my finger would be exerting a what force? An upward force or a downward force? What do you all think?
Sir, upward.
Megan, what do you think? Upward force or downward force? My finger.
Upward.
Good. And what's the proper name for that, Chanel? So, pick up yourself, Megan and Javon. Chanel, what's the proper name for that upward force? It's called a what? It was in the question we had done. What do you call the force that's reacting to the weight of the pencil?
Reaction force.
Right, reaction force. Right. Cool. So objects balance at a point called the center of gravity. You all saw that for yourself. The center of gravity of an object can be defined as the point at which the weight of a body acts. So you'll take a quick jot down of this and you can copy the diagram with the Apple Pencil and the center, and all of the weight is acting there. Right? The force of weight acts downwards from the center of gravity. Imagine it as a straight line vector pointing down from that position. I mean, you're seeing that, right? Like you can see that for yourself. It's a downward force at the center. I don't know how else. I feel like we understand that, do we?
Yes, sir.
Alright, bet.
Yes, sir.
Anybody here went to a 5K before?
Yes, sir.
It have 5K and thing in Jamaica?
Yes, sir.
I thought it was a big Trinity thing. I didn't know it was big in Jamaica too. What? Hey boy. I feel into a 5K, you know. I go on. Yeah. Adele, Marie, Megan, all ever went to a 5K before?
No, sir.
Yes,
No.
sir.
Megan, it was vibes. Wait, Megan, it was you that say you went, or was it Marie?
No, sir.
It was me, Marie.
Yeah, Marie was fun or not?
Well, it was exhausting, but yeah, it was fun.
uh, I want to go to one before the holidays are up. I'll do that. Everybody real bashing True Bread boy.
So yeah, I'm finding the place a little too hot for that.
True Bread?
No, the 5K.
Hey, I did some crazy stuff, you know. That's small thing.
Yeah, I saw.
It's small thing. If I find it too hot, I might take a dive in the drain.
Okay.
I'm joking. You think I will do that? I might. But
Yes.
hey, life is about living, eh? Having shame prevents you from living. I think. If you worry about what people will think and think, you're holding back yourself.
So I know it's a shame thing. You say a dream, you know.
You hearing things, I never say that.
Okay.
Yeah, boy. Make sure you drain clean. You know, in Japan, there's literally koi fishes in the drains because of how clean it is. It's crazy. Can't have that in Trinidad. Everybody want to dump their rubbish in the drain. Alright, so I think I should have the note and the small diagram copied down by now. I lapped enough. So I think you all should have it. I'm going to move on now. So somebody tell me what the center of gravity is defined as what? What is the center of gravity?
Sir, where all the weight acts on an object.
Exactly. It's a point where all of the weight for an object acts. If you were able to hold it at that point, the object would be in equilibrium. Great. Oh, that's another thing I should talk about. Equilibrium. Do any of you all know what equilibrium means? Do any of you all know what equilibrium means?
Remember the name, that's so good.
Say that again?
I remember the name, but that's all. It's
Okay.
like the middle point or something like that.
Alright. Does this look like equilibrium? If the pen just fall down. Like watch. Does this look like equilibrium? Oh, mash up my Apple Pencil, boy. Oh god.
No, sir.
Oh god. Be careful. Hey. Oh my days. Oh, look, give me a second. I get it in one try, bam. I think that's equilibrium.
Yes, sir.
Yes, sir.
Right. Marie, I'm more so concerned with you guys developing the intuition, because if you develop the intuition, you could lap in the exam. Right? If you forget like the fancy definition and thing, you could talk sense and you could get marks. Marie, in all the instances I gave you just now, the Apple Pencil fell down. But in this instance, it's staying here. What do you think equilibrium is? If this is equilibrium.
Like the balance.
Yes, that is it. Yes. You see how easy physics is? Like physics is just like, just intuition. If an object is balanced, it's in equilibrium, meaning that the upward and the downward forces are equal, meaning that they cancelling off. Also means the clockwise moments and the anti-clockwise moments are the same. We're jumping a bit there, but it's fairly straightforward. Let me show you what I mean by that. So guys, if I were to push down on the Apple Pencil here, will you see how it's moving? In a I can't tell if that's clockwise or anti-clockwise. That looking like clockwise on my end. Right? Will you see how it's going in a clockwise direction?
Yes, sir.
Yeah. That is what we call a clockwise movement. If I go to the other side and I push down, will you see it going in the opposite direction?
Yes, sir.
Right, that's an anti-clockwise moment. If it's in equilibrium, the moments are cancelling off each other, as well as the forces. Right, objects or systems that are stable tend to have most of their mass deposited much lower than unstable ones. I have a question. Let's just say I have this vase over here, right? I have this very, very, very long vase. And in the vase over here, I have this is lead. All of this is lead. Or I think lead is dense or lead is not dense. What do you all think? Guys, do you all think? Okay, do you all know what lead is? Oliver, hear your parents say like your head hard like lead? Oh no, I hear that growing up. Marie, you ever hear that?
Sir?
You never hear that?
Nope.
Probably you say like your head hard like manga. You ever hear that saying or not?
Not even that.
Hey, boy, again, oh, that's just crazy. Hey. Wow. Okay, but do you all know what lead is?
No, sir.
Okay. I'm totally not judging.
It's like a metal.
Yeah, lead is an extremely dense metal. Okay, I'm trying to use things here that all they could like reason with, you know? Give me something that all they could reason with. Like what all they know to be very heavy. Don't say the blankets early in the morning, eh? I don't mean like that. Right, Chanel? Right, Megan? Now I'm not talking about the blanket when you wake up. That's be heavy, but talking about things that are actually heavy. I'll give my example of something now. Fast. What's something that heavy? Gold? Okay, let me just say I have a bunch of gold over here. Bunch of gold. Where do you think most of the mass of this object is deposited? At the top or at the bottom? Somebody tell me. If I have this Megan, Chanel, Adil, where do you think most of the mass of this object is? On top or the bottom?
The bottom.
So do you think it'd have a... Okay, do you think it'd be easy to knock over then? Intuitive.
No, sir.
Guys, I would forget what the fancy physics are and think logically. If something is very heavy at the base, will it be easy to knock down? Megan, would it be easy to knock down if it's real heavy at the bottom? At the base?
No, sir.
No, it won't. Now, let's look at another example per se. Let's just say that we have a good bit of gold here at the top. So over there, real heavy. Would that be easy to tip over? If the top like real heavy? Guys, forget about the fancy physics and just think logically. That's all I want from all this. Just think logically. Use your brain. Megan, which one will be easier to topple over? The one that's heavier at the bottom or the one that's heavier on top?
You want heavy on the top?
Exactly. All of this is empty air, you know. This like real light. But we're here real heavy. If you just tip this over, what will happen? All of this mass would want to coming down. It would want to go down. You understand? Javon, Marie, Chanel, Adil, like okay, don't lie for me. If you don't understand intuition, that's fine. But tell me if you understand it.
Yes, sir.
Yes, sir.
Yes, sir.
if look at where most of the mass is. If you tip this, most of the mass is gonna want to come down. Right? It's gonna start to exert a force that's acting downwards. Over here, like all the forces are already acting directly downwards, so it's gonna be hard to tip over. That's what they mean in the question. I mean, that's what they mean in the statement here. We say objects or systems that are stable tend to have most of their mass deposited much lower than unstable ones. So they are said to have a low center of gravity, if that's the case. So let's look at the shapes below. Which shape over here do you think has the most stability? 1, 2, or 3? Talk to my guys. Which one is it?
1.
Somebody say 1. How much people going for 1 as well? Anybody else for 1?
Sir, 3.
Right, somebody say
1,
3.
sir.
So we have most people for 1. Let me ask you a question, Javon. If I only touch this, will it start a roll? If I like give it a little flick, will it start rolling?
Yes, sir. Yes.
So is it the most stable?
No, sir.
Nah. If I tip this a little bit, what would happen to it? Guys, if I tip this, what would happen? Would it resist that, or would it start to fall? Okay, what about this one with a base? If I tip this, would it be hard to fall over, or kind of easy to fall over?
Hard to fall over.
Exactly. So, if you see something like this that has a low center of gravity, that's very stable equilibrium, who would have thought? Guys, and if this is stable, what do you think this is? Guys? What's going on? I'm not hearing all that.
Unstable.
Right, this is unstable. Obviously, Marie, and you see why I say obviously or no? Does it look stable to you?
No, it's on its head.
Exactly. This one is neutral equilibrium. Why I say that? Earlier, imagine you kick a ball and eventually the ball will stop rolling. Guys?
Yes, sir.
Sir, go again.
Alright, so Chanel, imagine you're playing football. Do you play football?
No, sir.
Do you kick any... No.
Sir, I'll understand with the football example.
Right, so you're on the ground, right? And you're kicking a ball. You think the ball will roll perpetually, like forever?
No, sir, it will eventually come to a stop.
Right, it will stop. But if you only kick it again, what come?
It's going to move off again.
Exactly, so this is neutral equilibrium. Neutral meaning that it either... like if you don't kick it, it will stop. If you kick it, it will start rolling. Right? The point
Yes, sir.
the center of gravity never changes. Like I want to explain something. Chanel, over here, where's most of the mass?
sir.
Where's most of the mass? At the top or at the bottom?
The bottom.
Exactly. So if I place it like this, wouldn't the center of gravity go where most of the mass is?
Yes, sir.
Exactly, because the center of gravity is like where most of the mass acts. Well, that's a bad statement. Well, most of the weight acts. But if I take it and I place it like this, where's all of my weight? Where's most of my mass? To the bottom or to the top?
The bottom.
No. Look at this. Compare that to this. Where's most of the mass?
At the top.
Exactly. So if most of the mass is at the top, what will okay? Would the center of gravity get lower? Would it rise higher?
Higher.
Exactly. Higher. I want to show you all an example of this. Give me a second. I want you all to see it for yourself. Give me a second. I'm coming back. Okay, guys, I have a good example. So watch this carefully. Check this, right? I attached this thing over here, this cover to this pencil. Do you think that would throw off its center of gravity? Yes or no?
Yes, sir.
How about the rest of you guys? I attach like a weight to this side. Do you think it'll?
Yes, sir.
Yes,
do you,
sir.
do you think the center of gravity is still gonna be the center?
No, sir.
Tell me, Megan, Marie, Chanel, Adele. Do you think the center of gravity is still gonna be in the middle?
No, sir.
Sir.
Do you think it'll be closer to where the weight is, or closer to the other end that's lighter?
Closer to the weight.
Well, let me see. That didn't work. Let me see. Let's try the center. That didn't work. What about? Wait. Wait, give me a second. Look at that. Do you guys see how the center of gravity was thrown off by me adding that extra weight?
Yes, sir.
Yeah. So physics is just highly logical. Of course, if I add more weight on this side, it will want to go here, so I'll have to support it here. But right now, majority of the weight is at this point, so I'll have to place my finger closer to where this is. Are you all really understanding the logic?
Yes, sir.
Yes, sir.
It's the exact same thing that's happening here, you know. In this instance, most of my mass is at the bottom, so the center of gravity is going to be closer to where that is. The same way, guys, look at this. Over here, isn't the center of gravity close to where the cap is? Because I added the extra weight.
Yes, sir.
So over here now, where's most of the mass? Is it on top or is it at the bottom?
The bottom.
Exactly, so the center of gravity will be closer to the bottom because most of the mass is there. But if I take that shape and I were to rotate it or such, where is most of my mass? To the top or to the bottom? To the top. So that would cause my center of gravity to become higher. Do you all understand how center of gravity controls stability?
Yes, sir.
Alright, so if I want something to be stable, do I want a high center of gravity or a low center of gravity?
Low center.
Low.
Right, low. And let's look at this last one. This is a sphere. If you roll a ball is perfectly round. Does the center of a ball ever change?
No.
No, it does not. So the center of gravity remains unchanged no matter how it rolls. That's why it's neutral. So are we okay with these instances? CXC will bring this. They will ask you about stable, unstable, and neutral equilibrium, and they will ask you to describe the center of gravities. So you need to know this. Right. So I don't know if you want to. I don't know how much more you had to copy down, but take a 3 minutes and copy where you had to copy down. Stable, unstable, and neutral. Stable, unstable, and neutral. Guys, you're copying it down, right?
Yes, sir.
Alright, bet. Right, so Chanel, do you feel like you're actually understanding things from a logical perspective as opposed to just memorizing a set of formulas?
Yes, sir.
Okay. Megan, what about you? Do you feel like you're understanding the logic of things?
Yes, sir.
Okay. I do all it's just memorize formulas. That don't make sense. Alright, so when you'll have what's on your screen, let me know. You guys should have had this copied down already. You should have had the diagram. And I want you all to copy the text here. Objects or systems that are stable tend to have most of this is important, as well as the diagrams. Right, so Javon, you let me know when you have everything copied down.
Yes, sir. Sir, I have everything, sir.
Say that again.
I have everything.
Okay, nice. What about the rest of you guys?
Yes.
Yes, sir.
Alright. Badness. Right. So let's talk about something called irregular lamina. What's that? Let me explain. So you see how all of these are standard shapes, like triangle, circle. You know, this might be a rectangle, sphere. All of those are pretty standard shapes, right? Yeah.
Yes, sir.
Guys, what if you have a shape that looking like this? You gonna find the center of gravity for that. You understand? So
Yes, sir.
an irregular lamina's center of gravity can be found by boring holes and hanging a plumb line from each hole. I'll explain to you all what that means. Alright, the purpose of the plumb line is to see which points are vertically below the hole. By marking the lines, an intersection will be noticed. This is the lamina's center of gravity. So guys, the lamina, don't get confused, right? The lamina is just the irregular shape we're talking about. Lamina is the irregular shape. Irregular shape. Irregular shape. Right? And yeah, it could be found by boring holes and hanging a plumb line from each hole. So let me show you what that looks like, so you can actually see it for yourself. Would you guys say that this is a regular shape? The shape over here.
No, sir.
I would not say so. What about the rest of you all?
No, sir.
No, so here we
No,
want to do, right?
sir.
You want to put some holes at the outer part of the shape. Preferably at the outer part of the shape. You're going, by the way, do you all know what the name for this is? This stand over here. You all should know the name. Starts with R.
Towards time.
Yes, that's our retort stand. Right, that's our retort stand. So what you want to do is you're gonna bore some holes. You take a pin, and it's not in this diagram, but what you want to do is you want to take a string, and to the bottom of the string you're gonna put a slotted mass. Anybody could tell me why we have a string and at the bottom of the string are attaching a slotted mass? Anybody can tell me why I'm doing that? Megan is gonna help me with this. Megan, if I attach a mass to a string, what direction is the string gonna go? It's gonna be pulled to.
Downward.
Exactly. Vertically downwards. Because isn't the gravitational field strength on Earth going to want to pull it towards the center of the Earth?
Yes, sir.
Exactly. So in the actual experiment, you'll bore a hole, you'll put a pin, you'll attach a string here, and at the end of the string you'll put a slotted mass. The purpose of the slotted mass is to see the points vertically below the hole. So that's what you'll do. Then you'll rotate it some angle and you'll repeat the same process. You'll eventually see a point of intersection. That point of intersection is where the center of mass lies. Yeah, that's pretty much it. You'll understand it or not?
Yes, sir.
Alright, so I'll go over it again. An irregular laminar center of gravity can be found by boring holes and hanging a plumb line from each hole. So what exactly is the plumb line? Again, you have a string here, you attach a slotted mass, that's the plumb line. That's the plumb line, guys. Understand? The plumb line is the line that's formed by the string being pulled downwards. Let me know if you're okay. Guys?
Yes, sir.
Maybe I should get a different diagram. But has this string? Let me do that. Alright, check this out. One moment. One second. I check this. Masagon. Check this out, right, guys? I don't think you'll see my screen though. One moment. You'll see my screen?
Yes, sir.
Great. So can you all see that the person they bore some holes, you know, in the irregular lamina, and they have a string here. Listen, the string.
Yes, sir.
Yes,
What?
sir.
What do you think is causing the string to go downwards? What do they have attached to the string?
Sir, wait.
A weight. Well, really a slotted mass. A weight is as a result of mass. You should
Yes,
say
sir.
slotted mass. And this is a better look of it. Yeah. And you see this line over here as a result of the slotted mass pulling down on the string, it's a plumb line, and they call this a plumb instead of a slotted mass. That's why they call it plumb line. Yeah. Are we okay when it comes to this?
Yes, sir.
Yes, sir.
Yes, sir.
Alright. So y'all could copy this down quickly. You can just put irregular lamina. You can say find any center of gravity of an irregular lamina. That's what you can put for the heading. Finding the center of gravity for an irregular lamina. Marie, wait, sorry, not Marie, Megan. Megan, I need to make a point, right? The lamina, what a lamina actually is just a 2D shape that has like a weird shape, right? So like, Megan, imagine you have a piece of paper and they cut a weird shape, that's a lamina. A lamina is not a 3D shape, it's a 2D shape. I just need to emphasize that. A lamina is just a piece of paper that's cut in a weird shape. Understand?
Yes, sir.
Alright. So we don't have this and as well as the diagram copied on, you'll let me know. Okay guys, let me know what's happening. If you'll actually send me a picture diagram of the irregular lamina, I want to see what they do. Right? Send me a picture of the irregular lamina diagram so I can see what they do. I'm waiting. So send me a picture what you have so far in terms of your notes. Anybody? Megan, Marie, Chanel, Adil, Javon. Send me a picture of what you have so far. Okay, cool. Megan, I feel like it's just like damn, that's a really accurate representation. I feel like I was just looking at the exact same thing. Yeah. By chance, do you draw? I feel like it is draw. I never feel it.
Yes, sir.
And I think like our family, like Dwaraka people, I don't know if that makes sense, but like a lot of us draw. I look if you like in my family, you know. I wouldn't be surprised if you're like my like niece or nephew or like I don't know, like something so.
Probably.
Nah, I'm pretty sure. I can't claim you as my family.
Okay.
I mean, it's the same last name, you know. How much Dwarakas have you ever met before? Be real.
Um,
Other than your family.
Probably you.
That's what I'm saying. They don't have much of us. Yeah. Alright, so Chanel, good job, good job. Chanel, you have a nice handwriting. That's nice. One thing,
Thank you, sir.
one thing that's kind of wonky about your diagram. These plumb lines are directly vertically below the point. Yours looking a bit slant. Nah. Had to be like directly, you know, like perfectly straight.
Yes, sir.
Because if you attach a master string, it wouldn't be looking like that. It will want to go to its equilibrium position like this, directly vertically. Yeah. So I'm waiting on a diagram from Marie, Adele, and Javon. Our call is a day. We should be okay with mass and weight now. Should be okay with this. We should be okay with equilibrium. The three types. In next class, we're gonna move on to forces. There's a bunch of different forces, and hopefully we should start principle of moments, which is what I showed you guys with the Apple Pencil. Yeah. Fun stuff, fun stuff. So yeah, guys, hope you all have a wait. I'm still waiting. Marie, what going on? Javon, Adil.
My hand kept shaking.
I'm waiting, guys. I'm waiting. Megan, would you like to see some of my drawings?
Sure.
I'll share, I'll share. I drew this the other day. Wait till I'm just send it. It's actually quite small. The drawing is actually quite small.
That looks nicer.
And these are like ancient drawings from when I was like a teenager. Which is not that long ago, but still. Check it out. It's like old drawings. Alright, so Marie, Javon, I'm waiting on your diagram. Okay, I see Marie something. Yeah, Marie, I will take that. Just Marie, don't forget to put like the hole, right? Like the hole, because remember, you put a hole and you put it in a pin attached to the retort stand. So you need to indicate that there's a hole. Alright, so alright, cool. So guys, we'll call that a day. I'll see you guys in the next session. Take care everybody. Hope you all have a blessed Monday. Later.